Good morning, boys and girls, and welcome back to the Eastern wing of the Stink Bug Works. This morning, we're going through the process of building a wooden kit, and in fact, a rather old wooden kit. So some of the technology in the kit, some of you folks may not be old enough to remember. But what we have here is die-crushed parts. And yesterday I had built the frame and attached all the formers and the transom, but I had not yet put in the keel. And pretty much everything was just thrown together because you'll see, well, here I don't know if you can see, but there's a big gap and it's now filled up with epoxy and shredded fiberglass. One of my viewers asked, why don't I just use CA glue? And yeah, I could do that, but it's not about how fast you can build it. In this case, I'm using epoxy for everything. I'm using it for the adhesive, I'm using it for the sealer, and I'm going to use it for the finish. So I'm just going to stick with epoxy. I don't like putting CA on a joint and coming back later and putting epoxy over it because there may or may not be 100% waterproofing. If I do everything with epoxy from the get-go, I know I got it good. So you can see where I've filled in these really big gaps here with epoxy and milled fiberglass. Now, I said a moment ago, the first precise part I put in was the keel, and I did a couple of things that the plans did not say. I put a hole in it for the stuffing tube where the stuffing tube's going to come up, and I just measured on the plans where the Gazzetta is and the Gazinta is. And I also cut a groove in here for the, or a slot in here for the skid fin. It'll make it much easier getting them in and installed and such if I do it now. And then once it's skinned, I can come in with either a X-Acto knife or, if necessary, a drill and, drill out the bottom skin. So I thought I'd put those in now. Now, the precision. This is the first part that's got to be right, because what you're going to do is you're going to sand everything else to it and make everything else right. So this guy has got to be flat when he goes in. Adjust your slots and curves and such, and make sure that guy goes in flat, because you're going to take your nice big sanding block and you're going to be sanding to that block. Now, you don't want to sand too much yet because you still have to put on the chines. So I just have knocked things down to the appropriate height. The kit gives you balsa for the chines. I don't like balsa for the chines. I much prefer, here we are, I much prefer basswood. The tiny, tiny, tiny little bit of extra weight is going to be more than compensated with the strength. And balsa sands away so fast when you're sanding this, you could vaporize the balsa and still not get this where you want it to be. So the next step is going to be, I need to increase these notches to where the balsa, or the basswood rather, is just at the top of these bulkheads. So I need to notch these all a little deeper. That one looks deep enough. That one looks deep enough. In fact, it's a little bit too deep. That one's not deep enough. So I go in with a little flat file and just file those puppies down. So the goal is to get these stringers on. We'll wet them and ammonia them, and we'll bend them, let them dry. Then we'll epoxy coat them. Then we'll glue them in. So it's going to take a while. Yeah, I could just throw CA in there and be done with it. But that's not the way I'm going to build this. I'm going to build this like an old-time shipbuilder. All epoxy. I was looking at this motor. I may still use this mount. I might take this bracket that holds that bearing, flip it around, notch the bracket out to clear the motor, cut the back half of this mount out, and that way I could get the motors right there. I could get the motors right there. And that's my thinking, because that will work with the drive shaft. Now I'm going to take you over to the southern wing of the Stinkbug Works here in a little while, and we're going to talk about drive shafts. So I think I've covered everything I need to cover here. Until then, stand by. Welcome back to the southern wing, boys and girls. Sometimes these plans bleach out the video, but I think if I stand back here and put some shade on them, you can see them. Anyway, there's the profile of the boat. Or should I say, section. Do you guys remember these? These were the drive shafts from H&M. MHZ used to sell the same thing, but I don't see them anymore. Anyway, this used a 2mm wire and a M4 threaded end and fits M4 props, just like all those eco props that are available, those underwater eco props. And this is almost a perfect drop-in for that, other than it's too long. Well, this part's real easy to cut. You can see I've cut it. There's heat marks on it. And this part, you can warm up the aluminum and pull them apart. You know, I think they just put them in with, they might put them in with green sauce. If they put them in with green sauce, yeah, you got to get them good and warm, and they'll come apart. You can't really shorten this end because this end holds the bearing. So you want to keep the bearing. Some of the ones I was playing with, especially the ones for the jet stepper, they didn't have a separate bearing here. They ran the whole thing in a Teflon. Well, you would think a Teflon liner, but it was actually snug fitting and became the Teflon bearing. So there's an option for you folks that are building this boat and don't want to go through all the complexities of doing a gear drive. This would just be a simple drop in. I double checked it with the slot I cut in there. It's perfect. And you can put any little 24 series motor in here. You can run that little 4,000 kV outrunner, or quite frankly, any one of a number of 450 helicopter motors. So there's a ton of choices in this boat with this. And God, I'm half tempted to build a fleet of these things using these. Ooh. I wouldn't build them from the kit. I'd take this, scan it in, then bring it into AutoCAD, trace these things in AutoCAD, double check all the dimensions, because Where is it? This notch is not the same as that notch. And, there's a lot of symmetry issues because this was just all hand-drawn. I mean, folks, I want you to listen to what they recommend for radios. You'll get an idea of the age of this. You can get a single-channel tone radio, or you can get a single-channel pulse proportional radio, or the real cool guys had a single-channel proportional radio. Just think, proportional radio. That means when you move the stick, the servo moves proportionally with the stick. That was state of the art back then. If they only knew what we have now. We got transmitters that look like a darn porcupine with more switches and knobs. So single channel tone. It sent a tone, and it was either on right or off left. We live in good times, boys and girls. Until next time, jet out.